A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, course instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's lecture will be in continuation of the lecture 16 under module 7, which is to discuss about the construction equipments and the process involved in the production of bituminous bound courses. Now, at the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, in the previous lecture, we have discussed about some of the aspects related to the bituminous bound courses construction, where we discussed the preparation of the existing base over which any bituminous layer has to come up. So, there how the surface has to be prepared, it has to be ensured that it is firm, it is clean from any deleterious substances. Then considering whether it is a granular surface or a existing bituminous surface, the prime coat and tack coat application has to be done at the required specified quantities. And once that particular part is over, we need to look into the production of the mixes. So, there in the production of the mixes, we talked about the hot mix plant, because we have to have a plant where the different type of aggregates which has been proportioned during the job mix formula, the same proportioning can be arrived there in the field. And then finally the controlled quantity of binder can be added and the aggregates can be uniformly mixed to produce a homogeneous mix. So, for that particular purpose, we need to have certain facilities, specifically a hot mix plant can give us this desired targets which we want to have from a bituminous bound course. So, to begin again, just to have a quick glimpse, bituminous bound courses are extensively used in base, binder and wearing courses in flexible pavements, very popular specifically. And as I mentioned, to produce those mixes in a controlled facility, we require the hot mix plants, which is a central mixing facility. Some of the key features of those hot mix plants and requirements of those hot mix plants we discussed in the previous lecture. So, it is a central mixing facility having an adequate capacity depending upon how much quantity of mix that is required in the field for a particular stretch. So, being capable of producing hot bituminous mixes with uniform quality and thoroughly coated aggregates. So, this is a typical requirement from a hot mix plant, and the discussion will refer many codal standards, including some of them are mentioned here like MORTH specifications, road and bridge works guidelines for bituminous macadam, guidelines for selection, operation and maintenance of hot mix plant, a specification for dense graded bituminous mixes, pocket book for road construction equipment, guidelines on compaction equipment for road works. So, these will be referred during this course of discussion. Now, coming to a hot mix plant, basically there are two types of plants. One is a batch type hot mix plant and second is a drum type hot mix plant. So, we will start our discussion first with the batch mix type hot mix plant. Now, this is you can see this whole facility looks like here. On this side you can see these are the bins to take your aggregates of different sizes. So, since they are at ambient temperatures, we will call them as cold bins. So, these are the cold bins which receives the aggregates of different sizes. Now, from this particular one, the control proportion of these different sizes should go, and then there is a facility through the conveyor, it goes to a drying unit. So, there it gets dried up, this particular aggregates. So, is dried up and heated up to the required temperatures. We discussed about those mixing and compaction temperatures also, that at what temperatures with a particular grade of binder the aggregates are to be heated and the binder is to be heated. So, those temperatures needs to be attained here when you want to mix it with your binder. So, the aggregates are heated up and simultaneously you can see there is a dust collection system is there. Whatever exhaust gases are going to come, we are going to trap the dust which will be there. So, there are two set of controls are there. One is a primary dust collector is there and secondary is secondary dust collector which is there. So they try to trap whatever the dust which goes with the emissions, and we will look into reuse of it along with our aggregates as per the requirement, because otherwise we may fall short of fines specifically in the aggregate in the mix which we are going to produce. Now then they are particularly, once the aggregates are dried, they are lifted up, hot elevator is there, and then you can see it is mentioned at hot screens. We will discuss these components again individually, and then they get separated out again. So it is a secondary screening unit which we have in a batch mix type hot mix plant, and then they once they are again separated out into sizes and are stored in hot bins. Now they are heated up, so they are stored in hot condition, hot bins, and finally it goes to a pug mill mixer where you have the required quantities of binder which comes from your bitumen storage tanks, which gets added up to your aggregates in the pug mill. So for a particular lot which may vary from depending upon the capacity of that hot mix plant, specifically the pug mill. So depending upon how much lot mix is there in one particular lot, this adequate amount of binder will be added, it will be mixed in the your pug mill, and thereafter it can be directly transferred to the tippers so as to go in the field for laying, or if the production is more than what is actually getting transported, a requirement is there, for certain period of time it can be stored into your surge silos. So this is a broad explanation. We will discuss the components again. Now first of all, as I mentioned, comes the cold bins. So cold bins feeder typically consist of 3 to 4 bins. So we can accommodate at least 4 different sizes of aggregates, and as we discussed earlier that this avoids, if we have more number of bins, particularly this helps us to control the segregation there at the plant. So usually we have around 3 to 4 bins in a typical hot mix plant. So to hold aggregates of different sizes. Now each bin at the bottom of it has a gate, has a graded scale, and it has a graded scale to control the gate opening and regulate aggregate flow. So it opens the gates at the bottom, and then the auxiliary conveyor is there which takes the aggregates from a individual bin. So it will take from individually bin and then transferred it to the gathering conveyor. So all these bins will be transferring from their own auxiliary conveyor to the gathering conveyor, and then the gathering conveyor comes, and there is usually a provision for a single deck vibratory screen. So here you can see the gathering conveyor has come, and this has transferred the material through this single deck vibratory screen. Specifically this is installed so as to separate out any large size particles which have by mistake is present in these different aggregates which we are using. So we will separate those oversized aggregates with this vibratory screen here. Once this is there, then you have this plunger conveyor which takes this particular one from this one to the drying drum. So the dryer, it is the aggregates once they are screened, and then the slinger one takes the material to your dryer. So the cold elevator or cold feeder conveyor, also called slinger conveyor, transfers aggregates from the gathering conveyor to the dryer drum. Now let us look what are the key features of a dryer drum is there. Normally, usually these dryer drums are revolving cylindrical drums having a diameter of around 1.5 to 3 meter and length about 6 to 12 meters, and they are placed in an inclined position. Now what it includes? It includes a burner and a blower fan. So there you can see in this particular picture here, this is there. So which provides a primary air for combustion of fuel, whatever fuel which we are light diesel oils are typically used specifically in the conventional plants which we use in India. So for combustion of fuel, and an exhaust fan to create a draft through the air. So an exhaust fan is there, so a draft of this air is created in this particular dryer. So this is, and inside this particular one you have this longitudinal channels. You can see these longitudinal channels are here. So, this is an inside look. So, these are longitudinal channels which are also called as flights, and these are mounted with nuts and bolts, and what the specific purpose is there with it? It lifts the aggregate, whatever the aggregate which comes from the cylinder conveyor, this is finally lifted up by these flights and drops it in ways through the burner flame, so that they gets dried up and heated up. So, it moves, they moves along the dry drum, and with the help of these flights they fall and through the burner flame, and that helps them to get dried up and heated up to the required temperatures. So, it is very important to look into the dwell time which is there, especially for the time which it remains in the dry drum, because that will help us to give the temperature or to attain the temperature which is required for mixing these aggregates with the standard grade of binder. So, the dwell time, the retention time for aggregates in dry drum mainly depends upon what slope of the dry drum, at what inclination it is, revolutions per minute, diameter which is there, length which is there, number of flights which are present, their arrangement, how those flights are arranged, and the efficiency of burner, how good that burner is to effectively heat those aggregates. So, these are some of the key features of the dry drum. Now, here the important part is that we need to, there may be some natural moisture content which may be present in aggregates, which may vary from 2% to 4%, or even in some cases higher, up to 6% is there. Now, more is the moisture content, more time is required specifically for reaching to the desired temperature, or the production capacity will get reduced, because if there is more amount of moisture, it will take more time in the dry drum to heat it, to first dry it and heat it to the standard temperature. So, normally dryers are designed to heat and dry the aggregates of moisture content up to 4 to 6%, and their capacity is also mentioned accordingly. Many a times you can see the capacity is mentioned, two capacities may be shown, 40/60. So, for 40 may be a capacity when higher moisture content is there, 40 tons. So, 40 tons per hour or 60 tons per hour. So, depending upon how much it can produce it, and that usually depends highly on the moisture content of the aggregates. So, if moisture content of aggregates is higher, the feeding of aggregates into the dry drum is reduced, because more time is required and lesser quantity of load has to be there, resulting in drop in hourly production capacity of the plant. So, the production capacity of plant will get reduced. So, the aggregate, now it is also very important to ensure the temperature to which the aggregates are heated up, because as soon binder is added to the heated aggregates, it very quickly takes up the temperature of the aggregates, and if the temperature is high, then it may lead to your aging of binder. So, we want to avoid excessive heating of aggregates. We have seen that we do not prefer to go for temperature difference between aggregates and binder by more than say 14-15 degrees centigrade. So, the aggregates heated at high temperatures can harden the bitumen during mixing. On the other hand, if underheated aggregates are there, then it may not have a proper coating of bitumen. So, that is why the adequate temperatures which have been recommended for different grades needs to be achieved through these drum dryers. Aggregates should be therefore heated uniformly at appropriate temperatures to achieve a homogeneous mix, homogeneous and a uniform coating of the binder over those aggregates. And I mentioned, in many of the hot mix plants, light diesel oil or furnace oil is primarily used as fuel for burners. Now, at the dryer we have the dust collection systems, because it has to be highly ensured that it does not lead to environmental pollution. Whatever best we can do at the hot mix plant to reduce the any damages or any harms which is done to the environment. So, for this particular one, we have dust collection systems, or we can call them as pollution control, or so it can be called primary pollution control system or primary dust collection system or device also. So, its main purpose function is to remove any undesirable amount of dust coming from the exhaust. So, we want to trap that particular one, and specifically there are two types there are two stages of this particular one, is primary dust collection system and secondary dust collection system. So, the primary dust collection system is basically is cyclonic in a shape. So, where the dust is collected or separated out using this centrifugal force, and it is separated out from the exhaust gases, and this can be reintroduced depending upon, because if a good amount of dust is getting lost, then the fines may get reduced in your mix. So, this may hamper your performance, or the desired quantity of different combinations of aggregates may get hampered. So, we may have to reinsert, or we have to re-add this particular fine dust which have been collected at the primary dust collectors. So, and how much quantity is to be introduced, that needs to be taken care. So, it is fitted at the rear of the dryer drum. You can see this is what your primary dust collection system is. So, primary dust collector system is there. The fuel gases leaving the dryer drum passes through these dust separators, cyclonic type dust separators are there, which separates the dust particles. In addition to this particular one, the exhaust stack is there. So, here again before passing the exhaust gases through these exhaust stack, they are passed through the secondary dust collector systems also. So, the exhaust gases are eliminated through the plant exhaust stack. These gases further pass through the secondary pollution control devices. Many a times they are called as baghouse filters. So, baghouse filters are there, again they are to trap the fine dust which is there in the exhaust gas and for further filtration, and thereafter those gases are left to the environment. So, these are two very important components from the point of view of environmental aspects. So, it has to be well assured that we have a good primary and secondary dust collection system. Then comes, once you have these aggregates which are heated up to the required temperature, we have this hot elevator. So, the aggregates after heating and drying are carried up by a hot elevator, a bucket conveyor system, to the gradation unit. So, again to the hot screening unit. So, once this is done, you can see this is your drum. Once this is there, then you have this hot elevator. This is the hot elevator which is there. So, through this particular one, this bucket type hot elevator, it is taken up, and then you have these screening unit, hot screening unit. So, this is a picture of it. You can see this is the aggregate which has been taken from the dryer, and now this is the elevator, moves up the hot elevator, and it goes here in hot aggregate screening unit. So, this is what a screening unit is, and this is normally referred as a secondary gradation. It is also known as second gradation unit, because what we do, again there are different sieves where the aggregates get separated out into different sizes. So, the secondary gradation of aggregates in hot condition is carried out in the screening. You can see this is how the aggregates falls over it and get separated out into different sizes. You can see depending as per the sieves, fine aggregate separated out, medium coarse aggregate separated out. So, in case of, this is a specific feature of batch mix type hot mix plant. So, this is also known as second gradation control unit of hot batch type mix plant. Now, once this is separated out, these different sizes are collected into, from these particular screening units are collected into these hot bins. You can see. So, hot bins are there. These are, earlier what we referred was cold bins. Now, after this dryer unit, after this hot elevator screening, we have these hot bins. So, these are used to store the heated and screened aggregates of various sizes for a temporary. Now, we are going to release the individual quantities as per our requirement for producing the mix. Now, once they are stored, you can see these are stored in different hot bins, different sizes are getting stored. Now, there is a weigh hopper. So, this weigh hopper says that we are going to open this particular one, a standard weight is going to release, and that will ensure, okay, that quantity of weight has been released in this particular one, the gate will get closed. It will come for the next hot bin, then the gate will open, the required quantity will be added, and the weight will be, when the weight reaches to that required quantity, it will be, because all this goes through a control panel, this gate will get automatically closed. And then the third one. So, like this way the different sizes are getting collected in weigh hopper. So, the aggregates are withdrawn from hot bins in desired quantity through load cell and accumulated in the weigh hopper. Now, you have the desired quantity, what is there required from each size of the hot bins. Aggregates thus collected in weigh hopper are transferred into, now once this is there, then they get transferred to the pug mill. So, thus collected in weigh are transferred into pug mill, where they are blended with the desired quantity of bitumen. Now, when it gets transferred to the pug mill, here you can see this is the pug mill. So, from these from these individual hot bins, it goes to the weigh hopper, and from the weigh hopper it goes to the pug mill. Now, there in the pug mill we need to introduce now with these heated aggregates the required quantity of binder also. So, there should be a binder measurement system also. We say this is a weighing cylinder we have, and this is the pug mill which has been shown here. Now, what it says, the bitumen unit, the unit mainly consists of a bitumen tank, heating system. There are various ways of heating the binder in those bitumen binder tanks, and bitumen pump is there, delivery pipe is there. So, bitumen is weighed separately, it goes into this weigh cylinder, the required quantity is weighed, and then it is inducted into your pug mill. So, that for a particular lot which has come up in that weigh hopper and transferred to the pug mill, for that particular one the required quantity of bitumen in heated condition from the weighing cylinder will be transferred to your pug mill. And there in the pug mill, then the mixing starts. And there also it is important that normally the space which is there in these pedals and the surface of your pug mill is half the maximum aggregate size, and we prefer to ensure that it is not overfilled also and it is not underfilled also. So, usually we will try to fill up to this particular brain, so that we get a more homogeneous. So, it is important that the lot should be of such a size that it gets uniformly mixed. If it is of a very less quantity, as you can see there, then also it will not get mixed. If the quantities are very high, there will maybe certain amount of mix which will remain unmixed. So, that is why an adequate quantity has to be added, and this will depend upon many features of the pug mill, including the pedals which are there, the shape of the pedals, the number of the pedals, all these will be playing a role into it. So, pug mill, it is the chamber in which bitumen aggregates are thoroughly mixed to achieve a homogeneous mix. So, there it requires a time to mix your hot aggregates with the hot bitumen, and finally, once that is particular mixed, either I can directly transfer it to a tipper, or I need to transfer it to some storage silos for a particular period of time, and then later on it can be transferred as per my requirement to the construction site through tippers. Now, there is another type of hot mix plant quite popular, it is a drum mix plant. Normally, the batch mix plants, they are installed because they have a higher capacity. Usually their installation cost is a bit high, their maintenance cost is bit high. So, they are, but their gradation control is quite good. So, specifically for big projects where the production capacity is to be high, we can go for, always prefer for a batch mix plant. Otherwise, for a smaller production capacity and for a smaller project where the installation is also challenging, the cost is certainly a concern, the drum mix plant is also quite popular, and by taking care of all the operations during the drum mix plant, a good homogeneous mix can be produced through the drum mix plant also. So, in drum mix plant, the important feature is that aggregate gradation is controlled at the cold feed, and aggregates heating, drying and bitumen mixing are done mainly in the same drum. So, this is a unique feature which is there, because there is no hot elevators which are there, hot bins are there. This usually happens in one or many a times a second drum in that case. So, this takes place, there is no hot elevator to lift it, to separate it out, it is not produced in batches, and it is a continuous production which happens. So, that is why many times called as continuous production or continuous type of hot mix plants. So, those are your drum mix plants. So, some of the specific features are its portability is small, so it can be placed comfortably, high efficiency because continuous production is there, the rate of production can be higher. Economy is small, it requires a small space, a small installation cost. Similarly, because capacity is low, fuel consumption is also low. Maintenance is bit lower compared to your batch mix plant, and you can produce it at relatively large quantities of a mix can be produced at a relatively low temperature. Now, in this particular one drum mix type hot mix plant, there are two types of plants, further classification into two types. One is a parallel flow type and second is a counter flow type. These are the two main classifications under the drum mix plant, and what is the main difference between this particular one is the way in the direction in which the aggregates are inserted and the direction of the flame. So, as we have seen, there is a dry drum is there where a flame is there and the aggregates need to be dried and heated in that particular drum. So, in case of parallel flow drum mix plant, aggregates and hot gases flow in the same direction inside the same drum. So, I can see here, you can see this is the parallel flow one, these are the flame gases which has to be there in this particular direction. The aggregates are also entering and going in the same direction. So, they moves in the same direction here in this particular one. Here specifically you are saying, you can see some term RAP is mentioned, which is reclaimed asphalt pavement. Normally when we will discuss about the recycling of asphalt pavements in later modules, we will discuss, because if that existing old bituminous material is required to be used in production of these new mixes, then they need to be introduced. So, here you can see there is a facility to introduce that reclaimed asphalt pavement in this particular drum at a certain length, and then once it passes through flame, it reaches here, then there is an addition of binder which is there, the binder is sprayed and the hot mix, the bituminous mix comes out. So, this is the specific case for parallel flow type drum mix plant. Second is the one which is most of the time preferred is a counter flow type drum mix plants. So, here aggregates and hot gases flow in opposite direction within the same drum. So, you can see this is the one where the flame is there. So, this particular one is in this direction, and what your aggregates which are going to enter here, this particular one will be, this is the exhaust system which is there, exhaust for the exhaust system, this is the your virgin aggregates which are going to enter into it. So, they are entering into different directions. So, it may be there that once the aggregates are dried, heated up, then there may be small drum facilitated for mixing the hot aggregates with the bituminous. So, under the counter flow type also there are specifically two types are there. So, the one is where drying and mixing of aggregates bitumen takes place in the same drum. So, this may be the one for the counter flow type. What will happen? The flames are normally inserted embedded at a certain depth, and then a portion of this drum will be available for your blending of bitumen, and then the bituminous mix comes out. And the second type of this counter flow type is one there one has dual drum plant is there, specifically for counter flow type, where the drying of aggregates takes place in the first drum, and then the dried aggregates are transferred to the another drum where the aggregates. So, there will be another drum where these aggregates and hot aggregates and binder will get mixed up. Nowadays, there are double barrel systems are also there, which is a concentric cylinder. So, there will be what will be happening, in one drum the aggregates are heated up, and then they are transferred to the concentric drum over it, where they get mixed with the binder. But these are the two most common one counter flow type drum mix plants. So this is again a complete picture which shows this particular one. Here you can see the cold filled bins are there, so 4 bins are there. Then you have oversized rejection screen which will be there. Then so a gathering conveyor which takes to the oversized screen. From this particular one, the cylinder conveyor takes here. You have a bitumen tanks which are installed, where the binder gets heated to the required temperature. Then the material enters into your dry drum, which may be parallel flow, counter flow, and so the mixing takes place in this particular one. Specifically, you can see, and at a certain depth, after a certain length, the binder is introduced. This is the introduction of the binder. The exhaust system, again exhaust system should have a primary collector system as well as secondary collector system, as discussed in case of batch mix plants also. So the pollution control devices are there. Then once the hot mix is produced, it is again taken up, and a certain quantity of it can be stored into your gob hopper, or it can be taken to storage silos, and then from this particular one it is transferred to your tippers. So all these are controlled through a control cabin. It is a fully, most of the plants nowadays comes up with a full control. So sitting from this control unit, you can control the functioning of even cold fill bins gate opening, the speed of the conveyor belts, the speed of the dry drum, the time which is required, the revolution speed, all these can be controlled this from the control unit. So we have nowadays very good plants available under both the drum mix type, also the batch mix types. So as I mentioned specifically what is there, because you need to have a small capacity plant with a low cost, then this is quite preferred one. It is easy portable one, it is easy to install this particular one, and to modify it, as I mentioned in the case of introduction of a reclaimed asphalt pavement, some modification may be required. So that modification is more frequently done specifically with drum mix plant. So once the mix is produced, now it is important that it needs to be transferred. So when it is transferred, the tippers have to be clean enough, because there should not be any contamination which will happen. If that happens, it may hamper the quality of your mix. So bituminous material shall be transported in clean, insulated and covered vehicles. Covered vehicles, so that the temperature doesn't fall below the temperature which is required for laying the mix. The hot mix plant may be located far enough, because you can't put up your hot mix plants in urban areas, so they are located far enough as per the environmental regulations. So while transferring it, you can see this is, so you may have to clean up. So normally other part is, they should not get stuck to your body of these tippers. So we usually have a release agent which is there, so that when it goes to the site and it is emptied in paver, the complete mix goes out there. It should not remain stuck to the surface of these tippers. So release agents such as soap or lime water may be added to the interior of the vehicle to prevent sticking and to facilitate easy discharge of the material. So but the controlled use of release agent has to be ensured, otherwise it may hamper again a higher quantity. Uncontrolled higher quantity may hamper your, because binder is there. So these release agents may lead to concerns with your bituminous mix. So once the release agent is added to this particular one, then the tipper takes your mix, and it is to be covered. It is important, because unfortunately if some rainfall event takes place, and if the transportation requires some good amount of time, the temperature should not fall down. So that's why they are covered and then transported to the field. Now it is important to ensure, because under what climatic conditions or weather conditions, specifically weather conditions which are required for laying of these bituminous mixes. So some of the general recommendations which are there specifically for laying a hot mix asphalt, it says it should preferably suspended. So we don't go for laying of bituminous mixes under certain circumstances. And what are those certain circumstances? In presence of standing water on the surface. So there should be no, if some rainfall event is there, the surface should get, all the surface water should be should get removed. There should be no standing water on the surface. So when rain is imminent, the chances are there, and during rains, fogs or dust storm, if we have an idea that there are chances of rain as there, because then it becomes difficult. Once you start a hot mix plant, immediately you can't, it is very costly to stop it. So we need to have ensure it that at least a good quantity of mix is getting produced and laid once the hot mix plant is turned on. So when the base and binder over which particular this hot mix plant is damp enough, then also will not prefer to put a hot mix asphalt over it. Also it says when the wind speed at any temperature exceeds 40 km per hour at 2 meter height, then also it is not preferred, because that makes your temperature, the retaining of temperature difficult. So this is also one constraint. And when the air temperature on the surface is to be layered is less than 10 degrees centigrade. So even because then a very high gradient is there into your mixed temperature and the atmospheric temperature. So there will be a high fall of temperature will be happen, and which will make your laying as well as specifically compaction difficult. So we will not prefer when the air temperature on the surface on which it is to be laid is less than 10 degrees centigrade. This is specifically for unmodified binders, knead binders, viscosity grade binders which we have, and is less than 15 degrees centigrade for mixes with modified binders, because as we discussed specifically, the mixing and compaction temperatures are higher for modified binders compared to your unmodified binders. So these weather conditions are ensured. The surface over which, as we discussed during the preparation, needs to be again ensured that the surface is ready. There is no deleterious substance which is present over it. The tack coat is applied over that particular surface over which the this bituminous mix has to come up. So this needs to be ensured. Now once that particular part is done, now the mix is to be laid and spread over the width which is required for the construction. So for this particular one, a specialized equipment which is used is a paver finisher. This is how a paver finisher looks like. This is a pic of a paver, a traditional paver finisher which is there. Is quite popular in flexible pavement construction, specifically for bituminous bound courses. It is very popular for bituminous bound courses, and for non-bituminous courses also. When we go with the, especially with wet mix macadam, we prefer to go with these paver finishers. And for bituminous bound courses, definitely we prefer to go with these paver finishers. Main functions of a paver finishers are, what are the specific functions because of which they are preferred is to lay and spread the mix to attain specified surface, and this also needs to take care of the surface quality, correct grade, level, finish to meet the design specifications. So because these are my upper layers, upper bituminous layers, so they should have to be properly laid with a good control of the surface levels, a good control of the surface regularity has to be there. So this is, and that to done in a safe mode. So this specified equipment is required for this one, and to achieve specified camber and super elevation, because the at different locations considering the requirement, there may be a camber which may be cross slopes on both the sides, and at certain locations there may be a super elevation or a cross slope in one direction also. So that needs to be taken care or done with the help of your paver finishers. So it helps us to achieve required thickness, uniform degree of compaction also, because a little amount of compaction is given by these pavers itself. Homogeneous quality of mix during laying, because when, now what are the components here? You can see this is the hopper. So when this paver will move in this direction, so the tipper will come up with the mix and will get close to it and will drop this mix in the hopper, and then through the conveyor it goes here on the rear ends, and then you can see these augers are there. So the augers will distribute the mix over the entire width of these. Your screed is there. What is this? Screed is there, and the screed width is extendable depending upon what is your requirement. It may be say 5.5 meter, 7 meter, 10 meter. So screeds are normally, we have extended screeds which can be formulated for laying for the desired width, and this is how the control option is there. So when we do, as you can see, this is the tipper has come up, it is going to put up the mix in the hopper, then the mix from the hopper will come towards the screed, and with the screeds it gets distributed over the surface. So it gives you a control thickness of your mix. So it is important, what is important during this particular feature, it is important to regulate the material delivery rate so as to ensure continuous operation of the paver, because this is highly important. The mix, there should be a continuous flow of the mix, and simultaneously from the plant the paving capacity. So there should be no standing which should be there, that paver is standing because there is no mix which is available for laying. The paver speed and operating method should be so adjusted so that bituminous material spreads evenly. Otherwise, it may happen if you are going at a higher speed, you may push it hard. So there should be no dragging, tearing or segregation. So this you can very well see once the mix comes out of the screed. So by visual examination you can see there is no as such any segregation which is happening. A small segregation may take place where the joints are of the augers are there. So there some of the fines can be added through some manual skilled persons. So it is unrestricted specifically. Now this is a big attachment, this is a big machine which is to be taken up. So it may not be possible to have pavers in small widths. So in those cases, especially irregular areas where pavers cannot be used, such as what can be those cases, confined spaces are there, footways of irregular shapes are there, varying thickness are there, approaches to some joints are there. So there we can go with trained staff which can spread, rake it, make it to the desired levels and using appropriate hand tools. But this is only for specific locations where the paver cannot go for it. Now once you have laid it, and then you go with this particular one. So during this paver itself, it is a good amount of compaction usually, because these paver screeds have a vibrating arrangement as a tamping arrangement also. So they do a good amount of heating, tamping and vibratory arrangements are there. So they compact the mat during the laying itself, and many a times it attains a density which is around 85% of your maximum specific gravity. So this gives you some initial compaction for the rollers to come over the surface. So this is an important. Thereafter, once this particular one is laid, then comes into picture the compaction process. So bituminous materials shall be laid and compacted in layers, because there may be one layer of say even for a dense bituminous mixes, bituminous macadam, there may be a one layer of as a base layer, then a binder layer, and on the top there may be a wearing course layer. So different layers has to be constructed, and the different layers will have different thicknesses. The thicknesses of base courses are more than binder courses, typically more than wearing courses also. So different courses are to be will have different thicknesses, and they need to be compacted so as to have a uniform compaction and density which is possible. Compactions shall begin immediately after the paving, because this is very important. As the time is spent, the temperature goes down. So it is always preferable immediately, simultaneously along with the laying part, the compaction starts. And in compaction also there are different ways of doing it. There are different breakdown rolling is there, intermediate rolling is there, finishing rolling is there, that we will discuss in the upcoming slides. And longitudinal joints, because there may be an existing part which might have been constructed one day before, or maybe an existing pavement, then there may be a new one which we are laying, a new surface. So the longitudinal joints also to be rolled simultaneously. Rolling should proceed from the edges, as we have discussed in other cases also for unbound granular courses. preferably they starts from the edges and goes towards the center, especially not at the super elevated or unidirectional cambered sections which is there, where they process from the lower sections and goes to the upper section upper edges parallel to the center line. So, and this normally is continued till no roller marks all present, all roller marks are removed and compaction is substantially complete before the temperature falls below the minimum, and this is to be ensured. There minimum rolling temperature was mentioned. This all the compaction, the required density should be achieved well before the temperature falls below the rolling temperature. So, this is important. Now, as I mentioned, these rolling operations also with this bituminous mat, as good amount of compaction, initial compaction is done by your screeds also, vibratory screeds which have a heating arrangement also, tamping arrangements also. So, along with the pressure, heating, vibratory arrangements, it gives some initial densification. Then the first one comes which is known as breakdown rolling. So, this is immediately done behind the paver screed to achieve the highest density gain. This is the rolling where you get the maximum density out of the mix, and normally this we do with 3-wheeled static rollers. This can be very well done, this particular one, and within the given temperature constraints, because this is the initial part which is to be done, and it goes in synchronization with the paver speed. And preferably when these 3-wheeled static rollers are used for this breakdown rolling, they always proceed with the rear, because the rear wheels are the drive wheels. So, they are the one which have to be proceeded. So, they always proceed with the rear wheel drive moving forward in the paving direction. So, this is an important feature specifically when these 3-wheel static rollers are used. So, this is the breakdown rolling. This is important where you achieve the maximum density. Then comes the intermediate rolling. Once this is particular one, then it supplements the breakdown rolling. So, further to attain the required density, this is where we get the whatever the maximum density which is required, minimum density which is required, we gain during the intermediate density, and which is done specifically when the mix is plastic, that is it is still not stiff enough, so that it can get compacted during this particular time. So, this has to immediately follow with your breakdown rolling. Now, what is normally done, and here in this particular one, we most of the time we prefer to use these pneumatic tire rollers, and we call them as PTRs. So, it further, during this intermediate rollings, it further compacts the mats and reorients the aggregates for improved compaction. So, that reorientation. Now, for this particular purpose, specifically for this intermediate rolling, the PTRs, the pneumatic tire rollers, are highly preferred. Why? Because they give a uniform compaction, they enhance the surface sealing. Because of the kneading action, they enhance the sealing of the surface, which makes the surfaces impermeable to water. So, they helps to make the surfaces impermeable. So, the PTRs, and they helps to orient the aggregates for greater stability, which is normally done when the traffic actually comes over the surface. So, that is why PTRs are highly preferred. You can use vibratory rollers also, but PTRs are highly preferred for intermediate rolling, because we achieve, one is we achieve the reorientation of the aggregate particles. This helps us to enhance the sealing of the surface so as to reduce the permeability or to make the surface impermeable, and it gives a, because of the kneading action, it gives a uniform compaction also. So, what PTRs are preferred, as they provide uniform compaction, enhance surface sealing to reduce permeability, and orient aggregates for greater stability, similar to the effect of traffic over time. So, that is why these PTRs are highly preferred for the intermediate rolling. And then the finished rolling or the final rolling comes into picture, again to make the surface smooth enough, so that there are will make the surface smooth enough, and it is mainly accomplished with 6 to 8 tandem or tandem vibratory, but without any vibrations, while the material is stiff, warm enough, so for removal of roller marks. So, there should be no roller marks should be left after this finished rolling. So, this has to be done well before the temperature falls below the rolling temperatures. And the IRC SP 97 gives some guidelines about the speeds which can be followed for to achieve complete and uniform matte compaction. It says that if you are going for a static type roller, for breakdown, these speeds are in kilometer per hour. This can be a speed for breakdown rolling. If I am using for intermediate, this could be speed. This is for the finish one. As I mentioned, pneumatic one is the one which is highly preferred for intermediate rolling, and we can go for vibratory one also if pneumatic tire is not available. Now, here during this compaction process, certain rolling pattern is also plays an important role. We need to understand in what pattern the mat has to be, this bituminous mat has to be rolled. So, if say for an example, if this is an example where a rolling pattern behind the paver on roads with curbs. So, there are curbs on both the sides. So, there is some confinement which is there on the both the sides. So, you can see the first rolling pass which is going in this particular direction. When it goes here, and then it comes back. So, there it comes back. So, it goes towards, now here in this particular one, your paver is moving in this direction. So, it is laying in this direction. So, your roller is going in this direction, it reaches to the mat, then it comes back and it goes on the compacted part. This is the already compacted layer. This is what from here to here is your fresh layer which is getting constructed. Here to here, from this direction, from this place, the fresh construction is starting. So, it goes back on the compacted part and then it comes over it again. So, when it comes over it, it will do a small amount of overlap. So, you can see this shifting from one lane to the other lane is done on a compacted mat, not on this particular fresh mat. So, this is to be ensured. When it goes back here, again it goes on the third one and it comes back. So, this is how the rolling pattern, this is when confined edges are there. So, if confined curved stones are there, this can be done. If suppose there are bigger lifts are there and when there are no curbs on the sides, so without any curbs are there. So, in that particular case, it is preferred that the edges are not compacted first, because there may be chances that the mix may slide down, because the edges may not be protected enough especially. So, we will prefer to start with compaction, leaving certain spaces. So, it can be left around say 10 to 12 inches and then we can start with the first pass over it. So, this is, you can see this will start with the first pass here, will go for the second passes, will go for the third passes, and by the time what will happen, this particular one, the mat temperature, and so this mat temperature will go down. It will provide a confinement to this when we are doing a rolling at this particular part, and after certain time we will come back, and by the time this will become more stiff and we can do a compaction over this particular one. So, a pattern needs to be worked out and we can do very well with the trial stretches, with the different kind of mixes, to decide the number of passes and to decide the rolling pattern for it. So, trial stretches needs to be constructed over this. The rolling pattern not only includes the number of passes. So, this always is to be worked out with the help of the construction of some trial stretches, and then we follow those patterns on the actual construction. But also the location of the first pass, the sequence of the succeeding passes and the overlapping between the passes. So, this compaction exercise is again an art to achieve a good uniform density throughout the width of it. Now, in addition to this particular one, there will be the creation of joints. The joints will be a longitudinal joint may be there and a transverse joint is there. So, they also need to be taken proper care, because the density at the joints may be less and these joints may be more vulnerable towards distresses. So, we need to ensure that an adequate density is achieved at the joints. Now, where joints are, and always, because a one day construction work has to end up, next day when it is going to start, there will be a transverse joint will be created. And if I am doing, say, I need to do a width of 15 meter, I have done a width of 7.5 meter in one go, then the remaining 7.5 meter which has to be taken up, that will lead to a longitudinal joint. So where joints are made, the material should be fully compacted. Specific provisions has to be followed to properly compact along the joints, and the joint made flush with the previously laid surface. There should be no bump and no depression which should happen at the joints. Now specifically small important points which needs to be taken care is in multi-layer construction, specifically when you are having 2-3 bituminous layers to be constructed, the longitudinal joint in one layer shall offset the joint in the underneath layer by at least 15 centimeter. So if I am constructing, say, a bituminous base course, over that particular one a bituminous binder course is going to come up, then I will try to ensure that the joint on the top layer is having offset of at least 15 centimeter. Now this is for longitudinal joints. So when you are going to construct it in a number of layers simultaneously, as mentioned, because one day's work will stop, then the next day's work will be carried out, so transverse joint will be there. So there you need to note down where these joints have been constructed, what was the location, chainage at where the joints you came up, so that you are well aware when you are putting up the next layer. So these all information are well recorded while this construction operation goes on. So transverse joints in the successive and adjoining layers should have a minimum offset of 2 meter. So this is very important. If I am doing a laying, so this is one layer which is laid and a transverse joint was constructed, and when the next layer over it is to be come up, so then the next layer the offset should be at least of 2 meter if some joint has to come up over it. So this is highly important, specifically taking care of the joints. So the joints needs to be well recorded, well taken care, so that, because if these are the places, if the densities are less, if these are not at the same level, there will be a bump will be created, it leads to irregular surfaces, it reduces the riding comfort also, and these are the points which are prone to distresses at later stages. So this needs to be properly. Now once these all parts are ensured, the traffic need to be opened up, because during this particular construction part the traffic is to be closed and we are working over a particular lane during this laying process. Then it is always preferred that the traffic is not allowed on the surface until the paved mat has cooled down below a temperature of 60 degrees centigrade in the entire depth. Unfortunately, it should not happen that the laying has ended up in the night time and all the engineers have moved from the construction site and the traffic started plying over it, because in that particular case the mat is still at a higher temperature, it will distress your mat. So it is to be ensured that at the temperature for the entire depth, because at the lower end the temperatures will be higher compared to the surfaces. So that's why it is mentioned that the entire depth of that particular mat which has been laid should reach a temperature below 60 degrees centigrade, and we prefer that it reaches the ambient temperature. So around an overnight may be required for the mix to cool down, to come down to these required temperatures before they are opened for the traffic. So this is all for today's discussion. Thank you.